All right. So hi there. I forgot my clicker. That's my first fail. I'm Luc from ENS, or otherwise known as 0x225F137127D 90677888314BC7. Okay, I'll cut it. Otherwise known as Luc.Computer. And that right there, or Luismans.eth. And that right there is the core premise of ENS. ENS, thank you. Other room. ENS, the Ethereum Name Service, is a name service on top of Ethereum that simply turns human-readable names like Nick.eth into machine-readable addresses, such as 0xb8, C2s, 2, yeah, that. And backwards, so your address into your ENS name, as well as profile pictures. So this now means that all of these dApps that in the top right corner show your 0x225F1373 C3B5 address will simply show Luc.Computer as well as your profile picture. We don't want to see any more 0x addresses ever again. So before you run off, here's a couple talking points that I will be covering during this talk. If you're sitting there and you're going, yeah, I already know ENS, and this is not going to be interesting, hear me out. Wait till the end of this. Don't run off. Wait till the end of this slide, and then you can judge. So I'm going to be talking about what ENS is and how it works under the hood. Our latest DNS integration and the ability to now take your .computer, your .com, your .io, your .xyz, your .dev, or any DNS name, Web2 name you have, and bring it onto ENS and use it as your ENS name while it's still a Web2 domain name. Records and resolvers and the ability to custom program your ENS name and your avatar and all your records, subdomains, and a whole ton more cool stuff. Cross-chain interoperability, the ability to have stuff on other chains, off-chain, and have your toaster control your computer. How to implement all of the above? Well, not in detail because we have a limited amount of time, but if you want to know more, you can always ask me. And how to get your first ENS. So before all of that, I want to cover some milestones. These numbers are a little out of date. We've gone above and beyond after these, but we've hit 2.75 million ENS names registered recently. 506 official, in quotation marks, integrations. These are integrations that I'm in group chats with. These are integrations that are on our website and all that cool stuff, but there's a ton more sites out there using ENS. If you say, okay, we have a bit of a bigger project, we're taking off, we've got VC funding or something along those lines, and you want to integrate with ENS and you need help, or you just need someone to hold your hand and make sure you don't blow up, I don't know, things, message me. We'll start a group chat, we'll have a good time, and 593,000 individual owner addresses. So let's talk about that practical example from earlier again, right? This is Tic-Tac-Toe, a tic-tac-toe app that I built at ETH Paris a little while ago. Thank you, I appreciate it. Too much fun. Let's not talk about the design, but it works. You can play tic-tac-toe, and it does ENS name resolution, and as you can see, my other two wallets don't have ENS names. And if you check the top right corner right there, you can see v3x.eth, which is, at the time I took this screenshot, my primary ENS name. So ENS allows you to have multiple names, and you can set your primary name and change it as you go. So I have Luc.Computer, I have Luismans.eth, and I have v3x.eth. So I'm on Polygon. My tic-tac-toe game is on Polygon because I don't have the time. I spent 4 hours to build this during a hackathon. I was high, hypothetically, because it was Paris. And I decided that I wanted it on Polygon because ETH mainnet fees for my very not gas-optimized app were not going to happen. So here's our app, and now let's say you're sitting out there and you're like, okay, I want to try this out. How do I create a game? You press the create game button, you get this ugly screen, and then right there you can either type in their address or their ENS name. So right here we enter Nick.eth, you can see his profile picture, and you can see his address. Easy, ENS. So big flex, I am now playing tic-tac-toe against the founder of ENS. It's going great. Above and beyond my bad tic-tac-toe skills and the fact that this ended up in a tie, I think I know the winning strategy, but I keep forgetting. It's okay. This is a simple use case of ENS. We've got names, we've got profile pictures, and the dApp has nothing to do with ENS. If you do want to build something ENS specific, you're more than welcome to, but this is just your average dApp and an ENS integration. So that's the core idea of ENS. In this specific example, it provided the username and avatar. But we have a whole lot more than that. We have email, we have your GitHub, your Discord, your whatever other things you'd like to link to it. So this is me, Luismans.eth, or Luc.Computer, or v3x.eth, 0x225F1373, blah, 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 blah. and my profile picture. As you can tell, I do not like saying out loud addresses, so Luc.Computer it is. And this is Nick.eth. And Nick.eth is composed, I'm going to use him as an example because he has a lot more records set than I do, of a bunch of different records. So it's not just your ENS address, it's your ETH address, right? Your 0xB8C, blah, 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 blah. Your Doge address, because why not have a Doge address? Your Bitcoin address, because why not have a Bitcoin address? Your Litecoin address, and like a whole bunch of other chains that we support. Your website, if you have a centralized website. Your email, because email. Your Discord, your Twitter, your Reddit, your Telegram, your GitHub, your ENS delegate link in case you want to be an ENS delegate and you have a forum post about it, your avatar, and a whole bunch more. ENS names have key value storage. So all of these, if you lowercase them, except for the coins, they have numbers, but if you take website all the way to avatar, you lowercase them and you put them in your ENS name, and you put them in the records, they're just key value storage. So you can add anything you'd like. There are proposals out there. You can make proposals. You can standardize these things if you choose to. So there are a couple projects out there standardizing having audio in your ENS name. There's a couple projects out there standardizing all sorts of cool stuff, storing KYC in your ENS name, whatever you'd like, and it's optional, of course. So how does all of this work? ENS is composed of a couple core contracts, and their logic is relatively simple to understand. It simply stores for every name, Luceman.eth, the registrant, my address, when it expires, and a resolver address. That resolver address is just another smart contract. In this case, 0x497, I happen to know, is the public resolver. It's a contract that we deployed. It allows you to do key value storage, and it simply just checks if you're the registrant of a name. So it stores it for me, it stores it for Nick, it stores it for Vitalik, and it stores it for everybody else out there that has an ENS name. And that's the whole core contract. So when you have your library and your front end and your app is like, hey, I want to invite Nick to a tic-tac-toe game. I'm looking for Nick.eth. It'll go over there. It'll grab this Nick.eth from the list. And right there we go. Nick.eth registrant expires and resolver. It'll look at the resolver, and it will reach out to that smart contract. So this is the public resolver smart contract. And that smart contract will simply return all the information aforementioned. So we now have all of our information stored in that smart contract. Cool. This is the public resolver, like I mentioned. But this can be your code. This can be your contract. This can be everything from here on outwards can be fully customized. What this means is that your contract can return your ETH address and an avatar based on the day of the week, based on your profile picture, your portfolio, that is your profile picture, your whatever you'd like to do, what NFT club you've joined, or anything along the lines. Cool. So I get it. This is cool. You sit out there and you're like, yeah, ETH mainnet is cool, but ETH mainnet is not sponsoring this event. Polygon is. So you want to use the fancy things. And we get it. The ENS core team wants to use the fancy things too. All of these and more. And you can. There's a little thing that we released about halfway throughout last year, and it's the Cross-Chain Interoperability Protocol. CCIP for short, because nobody is going to say Cross-Chain Interoperability Protocol every single time they want to talk about it. So CCIP works very simple. It allows you to store your data on-chain, off-chain, on a rollup, on a layer 2, which, I mean, these are all kind of overlapping terms, using zero knowledge, using HTTP, if you'd like HTTP/CP to control your coffee pot, using your toaster, or anywhere else you would like. It is ridiculously powerful. So this is actually how it works behind the scenes. I'm going to give you a really quick rundown. It's all done client-side. These slides as well, if you want to take pictures, it's great, but they're also up on Luc.show. It's https://luc.show. You'll find all the slides as well. This right here is Ethers, a library that most of us use in our front end and our back end. And Ethers will reach out to ETH mainnet. It'll go, I'm looking for Nick.eth. Nick.eth will have the name, the registrant, expires, and resolver, just like I mentioned before. Oh, oops. The resolver, it'll go to the contract, and it'll say, hi, contract, I'm looking for Nick.eth. Get me its avatar. So get text, Nick.eth, avatar, or get text, Nick.eth, GitHub. Easy. The smart contract will then throw a custom error, off-chain data. And it will say, you need to go to Polygon, to this in this case, Optimism. Optimism, this smart contract, run this function. So Ether says, oh, shoot, the transaction failed, but I know how to handle this error code, off-chain data. So it reaches out to Optimism, or Polygon, or HTTP, or an RPC endpoint, or whatever chain you'd like, whatever L1, L2, rollup, name it. Optimism, or a BNB chain, or any other network that you'd like, will then execute a function, return some data, look it up in a database, God knows what, it's all up to you. Run your code over there. So if you run a registrar on Optimism, or if you run subdomains, your DAO is based on Polygon, all of that, and then it will return with, oh yeah, by the way, this is his avatar, and send you the URL. IPFS, Arweave, regular HTTP. Same goes for addresses, for Bitcoin, for Litecoin, for all of the other cool stuff. So I recently built a centralized version of this, which contacts a centralized API endpoint on one of my servers, and it is twitter.ngo. So I made subdomains of twitter.ngo. This was another 48-hour, quickly coded it together because I felt like a project. And what happens is if you take anybody's Twitter username, provided they have ENS in their name, .twitter.ngo, it'll go to the ETH mainnet smart contract. The mainnet smart contract will say, you need to go to Luc's server. It'll go to my server, and the server will then use my Twitter API key. Yes, you need a Twitter API key for this, but it works. Use the Twitter API key, make a request, get the user's ENS name, get their user's address, and then return all the information. So this now means that any Twitter user, provided they have an ENS name or an address in their actual username or description, is also automatically an ENS name. Congrats, you have a subdomain now. Sweet. So an example is Nick Johnson, or Nick SD Johnson, .twitter.ngo, that's Nick's username. And because he has nick.eth in his Twitter bio, all of the fun stuff happens at the back end. We've resolved it. It shows his ETH address, it shows his Twitter, it shows his profile picture, and it shows his description. Cool beans. So this is obviously super cool, right? But I understand that most of you are sitting here and you're going, where do I start? What is this? So there's a ton of libraries out there that already support ENS. If you're building a dApp, you're probably using Ethers or Web3.js. Or if you're doing something in the back end, you're probably using Web3 Go or Web3J for Java or anything of the sorts, right? Or just Ethers because it works in the back end as well. WAGMI provides React hooked wrapping Ethers. Super nice. So if you use RainbowKit, if you use Web3 Modal, if you use any of the sorts, ENS is already built in. And it's going to be one line of code away. So all you do is, for any of these cool libraries, and there are more than this, these are just ones I have worked with to make sure CCIP, DNS, and all of the other cool stuff is integrated. It will automatically have a get ENS name or use ENS name, use ENS avatar React hook for WAGMI, for example. I really like WAGMI because it makes dApps so easy. You simply just, for forward resolution, you simply just say use ENS address v3x.eth in case I try and invite v3x.eth to a game, and it'll just output 0x225f1373 blah, 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 blah. Cool. If I do it with Ethers, it's provider.resolve name, and there's a bunch more code examples in our docs. If you want to do reverse resolution, so showing your avatar and profile picture, look up address or use ENS name, and it will simply just work. It's that easy. And there's a ton more ways to do this. Use ENS avatar, etc., etc., etc. And then I haven't even covered subdomains yet. So my talk needs to be short, so I've yoinked out these slides, but there's more on the interwebs if you'd like to find some. If you want to know more, check out the documentation. Now, I see you going, yeah, this is cool. ENS or whatever, but how do I get one of these? Oh, wrong slide. How do I register one? So you use the ENS Manager. The ENS Manager is our dApp. It's both available decentralized and centralized, ENS.domains, and it allows you to register ENS names. But ENS is fully on-chain, and we are a true public good, meaning all the money spent goes back into the community, goes back into the ecosystem, and back into other public goods. Haha, I work for a nonprofit. But the ENS Manager is not the only place you can register ENS names. Because we're fully on-chain, there are community projects like ENS Ferry where you can give names to other people. Like Rainbow, that literally has ENS names in their wallet where you can register them, set them, edit your records, and all that cool stuff. Coinbase, they give out cp.id subdomains. Lens, any lens name .xyz is a valid ENS name. Argent gives out subdomains of argent.xyz. So a little bit of alpha. We're working on a new manager. Not to tease too much, it should be out ideally end of this year, beginning of next year. It's alpha ENS domains. If you'd like to check it out, it's purely on Gorley at the moment. But the real ENS Manager works around about like this. Here's what it looks like. It's app.ens.domains. You go to the search bar. Boop. You type in the name you want, so alice.eth in this case. And then there you go. Here's your registration screen. So any ENS name that's 5 characters or longer is $5 a year converted to Ethereum. So we use a Chainlink Oracle and we figure out what the current price is, and then it's $5 a year plus whatever the estimated gas fee is right now. So in this case, you can see that Alice is going to cost me about $9. This is on testnet, so it doesn't cost me anything. I press request to register, and we do it in 3 transactions, or at least 2 transactions in 3 steps. Transaction number 1 is a commit transaction. The reason we do this in 2 transactions is to prevent anybody whether that's somebody listening to your JavaScript code, somebody looking at your screen, somebody listening to your network connection, somebody running the ENS website, anybody in between will be unable to see what name you're registering until you actually own the name. This means that anybody who might be spying on you, might be listening to you, might have bugged your computer, will not be able to front run you and steal your name before you can register it. So the first transaction hashes the name and commits it to the chain. Next, we wait 60 seconds. This is done to prevent front running and for stability. After those 60 seconds, you make your second transaction and you send your actual $5 US worth of ETH. And now you have the name. Easy. So your profile looks around about like this. For the new alpha, it looks like this. It's super cool. And you have your avatar, you have all your records, you can edit them. The current manager allows all of this as well. It just looks less fancy. And you can do all sorts of cool stuff, like setting your avatar, which is super easy. So this is the current manager. All the way at the bottom right there, you'll see add and edit record. So you press on that, and then you scroll down right below the text records. I could show you if the internet was actually stable. That's your avatar. So you just put a URL there. This could be an IPFS URL, Filecoin URL, which is IPFS, an Arweave URL, an HTTP URL, anything of the sorts. And then you have your avatar. Easy. So I'm almost at the end of my talk. Don't worry. The next speaker can come up here in a minute. I have one last thing I want to do, and I apologize in advance to everybody here, but you've been rickrolled. My name is Luc.Computer. Luc.NL on Twitter. Luc.Contact has all of my contact information. If you want to WhatsApp me, Telegram me, Twitter me, whatever you'd like. Docs.ens.domains has more of the information. Happy hacking.